Hey, Amin, welcome to the show. You're live on the internet. That's my
Hi,
favorite thing to
Paul.
say is being live on the internet. Like that's a new thing. I think it's been around for a while, but you're here with us on the AWS OnAir show. Amin, why don't you go ahead and introduce yourself and not only introduce yourself, but tell us what you do. What would you say you do here at AWS?
Hey, so my name is Amin. I'm a software engineer at AWS. I'm part of the EKS service team, also known as Elastic Kubernetes Service. So basically, we build systems that manage Kubernetes for you, and we build some cool stuff around that we're going to show today.
That's right. Here at AWS, we actually have a managed Kubernetes service. We call that EKS, meaning that AWS manages the hardware and the patching of Kubernetes. And then all you have to worry about are your nodes and your clusters and your configuration of those things. But AWS kind of manages the keeping the lights on and the electricity feeding to those servers, right? That's what we got going on. And I mean, quick question for you. Is Kubehead a thing? Did I just make that up? Or am I going to start
Uh,
something here?
no, it doesn't exist, but I think it could be a very cool open source project for Kubernetes.
All right, I'm starting to hear. You've heard it here first on AWS On Air. CubeHeads, welcome to the channel. Hopefully that doesn't offend anybody. Okay, so Amin, we're talking about something that you've built recently for EKS. Is that right?
Yep.
When,
Today we're going to talk about Crow.
Crow. Crow is an acronym. What is KRO? What is it? What does Crow stand for?
Kube Resource Orchestrator.
See, I knew I was onto something with this CubeHead thing. Cube Resource Orchestrator, shortened as Crow, not the bird, but the new service, the new feature.
And so before we start unpacking the Crow itself and how to use it, for those who are experiencing or who haven't experienced Kubernetes before, I've got a challenge for you, Amin. Any chance you can condense, 7 years of history of Amazon EKS into what did customers ask for that motivated us to create a managed Kubernetes service in the first place? And then to the extent you can share, what have been some of those problems along the way that led you to creating Crow in the first place?
So sure, yeah, let's talk about Kubernetes first. So Kubernetes is a platform that let you deploy container workload on top of any infrastructure. There is something really cool that a lot of people love about Kubernetes is that it's purely declarative, and there's like what we call reconciler systems under the hood, meaning that you just describe your view of the world, and there will be a system under the hood trying to reach that desired state. Meaning that all you have to do is say like, hey, here's my application, here's the number of replicas I want, and you let the cluster go and figure out how to do it. You don't really think about where it's going to be running, how, if it's going to fail in the future. If it fails, there will be something behind the scenes that's going to fix it. So that's like a very short introduction to Kubernetes. Why do we build EKS? Well, if you really like go deep into Kubernetes, you can understand that's a very, very complex system to deploy. A lot of people say like, hey, I'm not going to use Kubernetes because it's very complex, which is very true. To manage your own Kubernetes and deploy it on top of your own servers or even on top of EC2 directly, it is very, very complex. So we built Amazon EKS to manage Kubernetes for you because we don't want you to deal with that complexity. You just hit a button, create cluster, we go and set up everything under the hood for you. And all you have to do is just go and consume Kubernetes API, do all the cool things that you want to do on top of it.
Awesome. So maybe if we fast forward now to 2024, 2025, more and more abstractions are getting created by the open source community. Things like EKS Cuddle, easier way to create a cluster. I don't even have to think. AWS controllers for Kubernetes, as we were talking about before the show, starting to automate in a Kubernetes way various things that you wouldn't have typically expected to talk Kubernetes. How did we get to Crow where we're saying, you know what, we need to now take care of custom resource? Can you help explain the world of custom resources? Like, what does that even mean?
Yeah. So one of the hottest features in Kubernetes is custom resources. And with that, we mean that Kubernetes is an extensible system, meaning like today, originally it was designed to deploy container workload, but today it can really do anything. It can create AWS objects, it can manage them, it can even order you a pizza if you want. Really, you can do whatever you want with it. And trust me, there is a controller, there is an extension for Kubernetes that let you order pizza right from your cluster. It's a thing. So that's the power of Kubernetes. It's a standard, it's an API, and people love that API. And it's pretty straightforward. And whenever you want to you want your cluster to do anything extra on top of managing workloads, you just go ahead and configure a custom, what we call a custom resource definition or a custom resource.
Yeah, I mean, we've got some folks joining the chat that are new to this world of EKS. Who we have one person in the chat just said they're new, but they haven't used it yet, but they're studying. So I think for folks who are just learning Kubernetes, we can talk a little bit about like containers. They sort of standardize the deployment configuration for the apps that run inside of them, and there's a couple of reasons why you would want to do that. I'm an app developer back in my earlier days of application development. Containerization was all the rage because it was like the whole it works on my machine problem, but then when we go to deploy, it doesn't work, right? So containers were a way to sort of solve that. Then we started getting into distributed computing. We want the same application running. We want more computational resources to be able to distribute the load across maybe different servers or different clusters. And that's when we talk about nodes. We have these nodes sort of orchestrating collaboratively to deliver some sort of application or some sort of functional purpose. And so containers, there's a couple different ways to do containerization, but Kubernetes is one of those. And you're saying that configuring and setup, all of that can get very complicated. And then you start talking about custom resources, which just gives another layer of complexity. But you've developed something called Crow that gives you even more power and control over those custom resources, from what I understand. Is that right?
That's correct. So if you really want to deal with custom resources in Kubernetes, like managing Kubernetes is very complex. There's a lot of systems that need to be built. There's literally like code that you need to write, a lot of configuration files and manifests. And with Crow, basically, we just removed all that complexity. No more code, just declarative configuration.
Yeah, kind of in line with like, I'm kind of like a history buff in programming, because I love the history of how we started with like literally punch cards where you have to like punch a 1 or a 0. It was either on or off, and that's how the machine interpreted. And then you get this next layer of abstraction, and we start talking like basic. We're not punching 1s and 0s, but we've abstracted away. But anyways, you get to this point where all of a sudden now we've got so many layers of abstraction between what we started with, and all that does is offer a more simple interface. Still the complexity underneath the hood there, or is what did Werner call it at reInvent? I love this term, simplexity. You don't remove complexity, you abstract it away. And so now we have this simple interface, but there's all this underlying complexity. And that's kind of what I hear, like kind of Crow is this next level of abstraction, removing complexity. And I'm talking myself up. I'm ready to see it. I'm like getting excited to see this demo. Should we bring up your screen and show folks how this works?
Yep, absolutely. I will share my screen right now. Are you able
we want to, and while you're pulling it up, I want to make sure that our checking in on our chat, they're not falling asleep on us on the keyboard. We want to hear your questions. We've got, he is an expert EKS, like whatever you wanted to know about Kubernetes, Amin's going to answer that question. I'm going to put him on the spot here. So drop your questions in the chat and let us know what you got for Cube. What are our Cube heads got? That's what I want to know. All right, Amin, it's all yours. Take it away, buddy.
Sure, thank you. So for today, I have very simple examples of Kubernetes. I wanted to explore a little bit with you all how Kubernetes looks like and why. What is the typical user experience in Kubernetes? So for today, I have a terminal. I'm gonna show a few manifests here and what is Kubernetes, what is ACK, and how Crow fits into the full story. And for that, I'm gonna be using a Kubernetes cluster that is already provisioned before this demo. It's running on top of EKS, and I have a command line. I have an alias I'm going to be working with called K, so it's just like an abbreviation of kubectl. And kubectl is just a command line that lets you talk to Kubernetes. So I can be like, hey, give me the cluster information, like where is the cluster running? And you can see here that we have a load balancer pointing to our nodes in AWS, and that we're ready to go.
So you have a cluster live, and I want to say hello to Adriana. She came on. She's watching from DC. She's learning about this topic. I'm learning right with you, Adriana. So we have a cluster up and running. That cluster has some nodes in it. Those are our compute resources. And you're just asking, hey, are you on? Does it work? and you're using a CLI to do that. So we've confirmed that it's up and running.
Yes, that's true. So
Okay.
I can, for example, here I can be like, hey, can you show me all the nodes that are running in the cluster? And you can see here that I have 5 nodes running on AWS, and they're connected to my cluster, ready to receive workload. I have only like few things running in here, but we're not going to show them for the demo. So typically in Kubernetes, if you run an application, what you would do is submit a manifest that looks like this. It's a very simple one. You're saying like, hey, I want you to deploy something. So the kind of the type of the thing we're creating is called a deployment. For this deployment, we want only 1 replica. I mean, we can also increase it to 5 or 10 for the high availability of the application. And for our template in here, we want to run a container that's an Nginx, which is just an HTTP proxy. And I want to expose everything to the port 80. So if you deploy this to your cluster, what's going to happen is that Kubernetes is going to consume this manifest in here, go and deploy it, and you're ready to go. This is literally everything you have to do in Kubernetes. But for today, we don't want to really like show applications. It's like a pretty simple example. We want to show a little bit more advanced things. So we talked about custom resource definitions and how can you extend Kubernetes to do some really awesome things. Well, for today, we have an example called an S3 bucket. So how would you create an S3 bucket from within Kubernetes? And some of you might question like, hey, why would I even want to do this? If you're a Kubernetes expert and you're only familiar with the kube hello command, the CLI of Kubernetes, or the Kubernetes work ecosystem, which is very rich and have a lot of tools around it, sometimes you don't want to leave your cluster or your environment. You don't want to go and learn new other complex tools to manage your AWS resources. What if we brought AWS inside your cluster? And this is what we have an example for today. It's like, hey, by extending Kubernetes, you can have something like an S3 bucket. And in this situation, I can ask the cluster to create an S3 bucket for me. And in this situation, I can do something like, hey, can you go and create this bucket? So you can see here that the bucket got created. If I do get buckets, I should see something called AWS OnAir demo. And if I hit list all my buckets and grab the AWS OnAir, I'm going to see that I have a bucket that just got created a few seconds ago.
So to recap, you could have created a bucket through the AWS command line interface saying, hey, AWS S3 create bucket. But now you're saying, hey, if you prefer to speak Kubernetes as opposed to speaking the AWS CLI, then you can declaratively say, hey, I want this bucket, and it will accomplish the same result through Kubernetes.
Yeah, I mean, I like the way that you said that you were bringing AWS into the Kubernetes world. And so if you're a diehard Cube head, you speak Cube. I don't know what the language would be, but Cube. You can now tell Cube through a familiar interface, hey, go do this AWS thing, and you don't have to go learn some other command line interface. That's a nice summary, Rebbe. I like that. And I mean, is this Crow? Did you just show us Crow? You went really fast there. Is that what Crow is?
Not yet. So
okay.
Right now we're just showing. This is called ATK. So this is AWS controllers for Kubernetes.
Okay.
It's an extension of Kubernetes. Actually, it's an open source project that is you can find on GitHub. It's free. You can install it and use it on any Kubernetes cluster that lets you manage AWS resources. You can name it DynamoDB tables, RDS, databases, I don't know, Lambda functions, whatever you want, you can find it there.
Yeah, cool.
So what we're not showing, so this is ATK. What we're not showing here that we have other attributes, like for example, you want to add tags, you can have like, hey, this is, for example, prod, tag name value, and you can have things like this in ATK. But for today's demo, we're not going to show this. This is like to show like, hey, you can have multiple flavors of Kubernetes, and you can do really whatever you want with it. So let's dive into a little bit, something a little bit more complex. In a typical world, when you're running an application on top of Kubernetes, you actually want both of these objects. You want a deployment and a bucket to be created, connected somehow together so it can work with AWS. If you've seen how we do this in typically in AWS, when you want to create a complex application, say you have an S3 bucket, DynamoDB, a few IAM roles, and let's say an RDS database, what you would usually use is something like CloudFormation or Terraform or CDK, because you really want to like simplify or create abstractions on top of all these like very small elements that can be managed one by one. So let's talk a little bit about Crow. Crow is exactly trying to solve this problem. Can we really have something like CloudFormation or CDK or Terraform inside of our cluster? I don't want to go and manage my S3 buckets manually. I don't want to manage my deployments. I want to manage an abstraction that will go and create a bucket and a deployment for me. And by that, I mean like, hey, I want something that looks exactly like this. I want just to provide an application, give you a name, my image, a number of replicas, and a bucket name. I don't care like how you're gonna do it. Just go ahead and provision a bucket for me. Go and mount, let's say, the bucket R into the environment variables of that deployment, and let me know when everything looks all right. So in order to do that, so if you want to like do something typically in Kubernetes, you will have to create what we call custom resources and build your own extension of Kubernetes by writing literal code and let it go and create your resources under the hood. But with Crow, you don't actually have to do anything besides just configuring Crow to do these things for you. So let's walk into what is like the equivalent of a construct in Crow. I want to create this new construct called application. I want you to go and whenever I deploy this, I want you to create a deployment, add up S3 bucket, and connect them together. So let's open this on the side. You can see here the first thing that we want to really teach to Crow or ask Crow to do is like, hey, we want an application and we want these 5 fields to be available to the user. And you can see here that in Crow on lines 6 to 13, all we have to do is provide basically this information that we see here, where we're creating a new abstraction called application. We want the users to provide a name, an image, a bucket name, and a replicas. And if not provided, I want you to give me a default number of replicas. And you can see in here the same way we defined a deployment before. This is how you do a deployment. You just go ahead and request from Crow to create a deployment for you. And you can see here that as well, we're creating an S3 bucket. So we have the store resources that needs to be managed by Crow. And you can see here that we're using dynamic names. We're saying like, hey, I don't want you to use a static name. I want you to go and use the bucket name provided by user, which is like here on our left, and use that as a name for the S3 bucket.
Yeah, I mean, I just want to give you a heads up. We got just a few minutes left, so I want to make sure that we get through. I like the side-by-side comparison. We're creating this construct of resources that often go together, and so you're making it easier with Crow by defining that resource set, that group of resources, and then you can just reference that group. But I want to make sure that we can kind of show this in action. We got just a few minutes left.
Yeah, sure. So let's go ahead and deploy this. The first thing you'll have to do in Crow is just go ahead and deploy what we call our resource graph definition, and I will get later to why is it called a graph. So I'm gonna go ahead and create the construct that we have in here. So if I do, all right, it's flying. It should be arriving soon. Okay, it's here. And if I do get RGD and I want my application, we can see that it's up and running behind the scenes in the cluster. Okay, now all we have to do is to provide the configuration in here, nothing more. We're gonna go ahead and do an apply. I want my app, and in this situation, we want an app called my app Nginx, and I want the bucket name to be created. AWS OnAir and some suffix in there, postfix. I'm gonna go ahead and create it. You can see that we created it in here, and all we have to do is get my applications. And it should be, oh, it was so fast. So in 8 seconds, it was already created, and it tells us that everything is active. And if I look under the hood, do I have an S3 bucket? Yes, I have something that got created 17 seconds ago. And if I check the deployments, we're going to see that we have an app of replicas 5.
Nice.
If I check the application internally, you can see that there is something extra in here that Crow injected the S3 bucket on inside the environment variable. This is just coming from the construct itself. You can see that here we'll define an environment variable this way.
Very cool. So I'm going to recap this while we are giving our audience one more chance to ask a question with you, Amin. So you've defined what the construct is and what should exist in that construct, and you deployed that construct to your cluster. And then once you've done that, you can reference that construct in one of your your Crow application configuration, and you can say apply this, and it knows because it's referencing that construct that it should create these resources within AWS. And what you just showed was one of those things being an S3 bucket, and now you can use the ARN and reference that ARN in other configurations.
Yep, that's correct.
Okay, I think I'm picking up what you're putting down. That's okay. It's cool. Any other questions from our chat? Let's see. Let's check the chat.
While we're doing that, where should folks get started to learn more, Amin? Go right to GitHub and get started?
Yeah, so Crow is an open source project. We open sourced it in November last year. You can go ahead and install it. It's on GitHub. We have a website called crow.run, which should be linked very soon. It's a very simple concept. There's only one CRD, only the RGD, so the resource graph definitions. And it doesn't really require AWS to get started. You can install it on Kind, and you can play with it with Minikube. I don't know, like pick your flavor of Kubernetes and you can install it and play with it.
Hey, I mean, we do have a question here. Does this, Code wants to know if this at all works with SAM or CDK constructs? Is there any kind of interoperability there?
So Crow lives inside the cluster. It's an extension of Kubernetes. So you have to install it into the cluster to run, while CDK is a client-side tool, so it runs outside of the cluster. There is something we call CDKs, and CDKs lets you manage Kubernetes resources outside of the cluster. So it's a CLI that could talk to your cluster. And technically, yes, you could use CDKs to create RGDs or resource graph definitions and manage them in the cluster.
So if you want to get real creative, you can get some a little bit of connective tissue there to get these things to talk. But this is a very Kubernetes specific tool set living inside the cluster.
Yes.
Cool. Hey, well, Amin, thanks for coming on. I hope folks go and check out your demo on GitHub and read the blog or the other resources that are posted in the chat. Thanks for the demo, Amin. Great work.
Thank you for having me.